This video is brought to you by Sporlan, quality, integrity, and tradition. All right, over the weekend, we had a service tech come out for another air conditioner, and while he was here, he noticed that the kitchen was a little bit warm, and he actually found that this unit had bad fuses. So he replaced the fuses, the unit started up, but I'm here to dig in a little bit further. So I want to figure out why the fuses could have blown, what's going on. So we're going to open this guy up. This, I think, is a 7.5 ton. Let's see if it says it. Yeah, you can usually look on the charging chart. It's kind of hard for you guys to see it, but on the top of the charging chart, it'll say 7.5 ton. Or right here, this is a Carrier. The 08 designates 7.5 ton. So, all right, we're gonna open this up and see what we can figure out. Doesn't look too bad. Looks like we've got a 407C compressor. We have an R22 compressor. Let's go in here and check to see if we still have, there's 206, 206. We're checking all three phases. Yep, so we have three phase. The fuses are not blown. This one right here, they do single pole or double pole contactors, and they just split it. So there's always a hot leg going to the compressor or the indoor blower motor. So we're not tripped at the moment on, we didn't blow a fuse again since he's been here last. So if we go from common to Y1, we don't have a call for Y1. We don't, oh, that's interesting. We have a call for Y2. Someone's got Y1 and Y2 jumped together, but we don't have a call for Y1, but we have a call for Y2. That's a bit odd, even though there's nothing hooked to Y2. So it looks like yellow is Y1, orange is Y2. That's very interesting. I'm gonna have to go down and look at the thermostat and see, maybe they got a mixed match. I don't know why they have them jump together either. So we're gonna investigate that. Looks like the transformer is tapped correctly. We're tapped for 208 volts, so I don't see anything crazy there. Okay, so it looks like we're just going to be investigating. We'll put gauges on it, trying to figure out if we can find an electrical short somewhere or what potentially could be going on here. Not seeing any voltage drops. What I am going to do right now at this point is we're going to amp the condenser fan motors. So this one, these are two different motors because this is an aftermarket motor. Looks pretty bad. I don't like the wires coming out the top. But this one's allowed to run 1.8 amps. And this one's allowed to run 1.4 amps. Let me double check. Yeah, 1.37 amps. So we're gonna test each of those motors and see how those are doing. Again, big picture stuff here, right? We're not just gonna jump at anything. So we'll definitely get in there and test those capacitors. So let's get in here, and I have to try to identify which wires are which because we have a whole mess of wires in here. So the OEM motor on the far side is running at 1.3 amps, and we're allowed to run, 1.4 or something like that, so, or 1.38 or something. So that one's fine. This one over here we need to test now, which is allowed to run 1.8. And this one's running 1.5, and you're allowed to run 1.8. So the condenser fan motors don't seem bad, but we're still gonna check, we'll pull the capacitors and check those two. And then at this point, we know the unit runs. I've seen it come on. I've seen all the stages turn on. So I'm actually gonna turn it off, and we're gonna start testing things. So I'm gonna open up these contactors, have a look at them, check those capacitors, open up the blower section, have a look in there. I am very surprised. These contactors look great. As far as like no burning, doesn't look like there's very much pitting at all. I know it's hard for you guys to see, but I got a little bit of a better angle. Those things look great, absolutely great. So I don't see a problem with the contactors. Let's get onto those capacitors now. This one right here is a 10 microfarad capacitor. I put a new battery in my meter, by the way. The heck? There we go. 9.8. So that is good because it's minus 5%. And this one is a 5 microfarad capacitor, and it's reading 4.8. So again, that's minus 5%. So both of these capacitors are good. Don't see any issues there, so we're gonna clean that back up. And then we're gonna open this guy up and investigate in here and make sure there's nothing funky going on in there. We come over to the disconnect switch and it looks like we're getting kind of hot on the incoming line, electrical line right there. And then look at fuse number 1. It's getting really hot on the top of the fuse, almost like it has a loose electrical connection. But then you come to the bottom and it's not too bad, right? Right there. So let's look at the temperature difference. So the bottom's about 73 and the top is about 90. So that fuse is definitely getting hot. As I come up here to this motor, these wires right here, we have no power, but these wires are very brittle. Like when I try to move them, they're hard and they're kind of cracking. So we're actually going to recommend replacing this motor. Now, it's not overamping and the capacitor's not bad, but the shape of the motor looks like crap. I don't like the fact that it's an aftermarket. I prefer to go OEM. We don't have to worry about these wires sticking out. Now, I was originally just going to move the wires inside, but because they're cracked and brittle, I don't want to deal with that. So that's going to get added to my list of things to replace. The disconnect's going to get added to my list of things to replace. Of course, I'd like to change the whole unit, but you can't get them right now. So yeah, let's get in here. We're going to test the insulation reading to ground. So I'm currently testing the old compressor. Now it's starting a little lower than I'd like it to, but it's building. Remember that an insulation test should not be an end-all be-all unless it's just a straight direct short to ground. So after a few minutes, this one's testing 540, 550. This is greater than, right? So greater than 550 mega ohms. I don't think there's anything wrong with that compressor. Let's go ahead and test the other one. The other one's fairly new, and that one actually in the past had a bad insulation reading. And that was part of the reason why it was changed. Okay, so let's test this one. This one also starts out low and then builds, okay? Remember that there's a lot of factors that go into an insulation test. I am not a complete expert, but I will tell you that Copeland has a technical bulletin that says insulation tests should be taken over time and the data should be trended, okay? But after holding it for a couple seconds, we're greater than 550 mega ohms. I think these compressors are fine. I don't see a problem with those, okay? The capacitors tested fine. The contactors tested fine. I'm looking at the wiring, just inspecting, making sure that nothing's rubbing out. I'm not seeing anything that's rubbing out. You know, nothing's perfect the way that it's installed, but I'm not seeing any reason for the compressors or anything to cause, besides the disconnect switch. We know the disconnect switch is a problem. So I'm not seeing anything there. So, yeah, we're gonna go ahead and open up this blower section now. In the indoor blower section, I mean, I'm not in love with anything, but this is a typical wiring on these things, right? So the wires don't seem to be rubbing out on anything. This is the only potential spot right here where they might be rubbing, and I don't see any damage to the wires. Don't see any damage there. They're going straight into the motor. There's a grommet in the motor. Don't see any problems there. I really don't want to have to pull the motor out, but I'd like to do an insulation test on that motor too. So maybe I get to the wires on this end and we test the wires and the motor. Now, ideally, when you're testing a motor or a compressor, you want to test directly at the source, because if you test at the wires over here, you could be reading an intermittent fault in the wiring, right? But if I test over here and I see a bad insulation reading, then I'll dig further and find out if it's the wiring or the motor. But testing over here shouldn't be a problem. Trace the wires back to right here. I isolated them. There's the black, the blue, and then I jumped on the yellow, right? And we're gonna go ahead and test it. And it's greater than 550 mega ohms. So I don't think there's any intermittent shorts in the wiring or the motor over there, so I don't think that's our problem. Since I have the insulation tester, I went ahead and pulled all the motors for the condenser fan motors and isolated the wires, and we'll go ahead and test those too. So let's go ahead and hit this guy. So one motor is greater than 550 mega ohms. That's this one. Don't see a problem. Now let's jump on this one. Should be good. Make sure it's nowhere near. Test that one. Greater than 550 mega ohms. So there doesn't seem to be any shorts or intermittent shorts or insulation damage, I guess I should say, in the condenser fan motors. So realistically, I'm not seeing anything else wrong with this unit. We have not put our service gauges on it yet, so we still need to evaluate the system pressures. But as far as bad insulation readings, I'm really not seeing anything. So we're gonna assemble this guy back together. We're gonna probe up on it, make sure that the refrigeration circuits, there's nothing funky going on there. Give it another chance to start up, make sure we're not getting any chattering of the contactors or anything like that. And then we'll write it up as a disconnect replacement and potential get rid of that aftermarket condenser fan motor with the brittle wires. All right, the system has been running for a few minutes. I am really not seeing anything too crazy. This is circuit 1. Circuit 1 is a 407C circuit. We're within reason. Sorry about the lines, it's just the camera. We're about 20 degrees superheat. We're right on the cusp. Everything's looking good. Subcooling's where I'd expect it to be. Let's go to circuit 2. That one's R22. Superheat's a little bit on the low side, but we also don't have a very big load at the moment because I have the system jumped out to turn on. So subcooling's a hair on the high side, but it's not horrible. Again, we're using discharge pressure. So let's scroll over, look at our temperature split. We have about a 17 degree temperature split. The expected target is about 18 degrees, so that's not bad. Airflow seems to be on point. And let's go back. And the return air temperature is 73 degrees, so you can see we really don't have a big load on the system. So this, refrigeration wise, I think this system is working properly. Don't see any big issues here. So realistically, I'm going to give the customer a call, the corporate office, make sure they're okay with me picking up a disconnect switch and a condenser fan motor, and then we're gonna see what that does for them. I've gotten approval from the customer, so our next step is decide what materials we're gonna need. So we're gonna need a condenser fan motor, pick up a blade and a new capacitor. We'll need a 60 amp disconnect switch with 45 amp fuses. We'll put 3 new fuses and 3 spares, so 6 fuses altogether. And then what I'm probably gonna do was, there was like big wire nuts in here. If I can, I'm gonna eliminate those wire nuts and do, this is number 6 wire. Let me double check. No, this is 2. Oh no, 6, yeah, this is number 6 wire. So I'll see if I can pick up some number 6 wire, and we'll make a home run from the disconnect directly into the contactors and won't be going through those wire nuts that they had, if I can. So I'm still assembling the unit. But you don't just you don't just look at the model number and take a picture of that and think you're gonna get everything from that, because these disconnects are field installed. So we'll go through it and we'll be back soon. So I had to drive all over the map to get a new disconnect, conduit, wire, everything, and a condenser fan motor, but we got it all. So old disconnect out, new one mounted. We're going to, I need to find a better solution here, because these chase nipples, the nipples are never long enough to get the bushing on the other end. I like using the plastic bushing on there too, so that way it has, you know, wire protection on both sides. But for whatever reason, I can't find the chase nipples that are long enough. If you guys have any solutions for that, that'd be great. But basically, I don't know if this is the right name, but I call this a chase nipple because it's rounded on this side, right? So the wires don't chafe against anything. And then usually you put a plastic bushing on the other end, but when you mount disconnect switches, the spacing between there is always so big that it's hard because of these offsets. So I need to find chase nipples that are bigger. But regardless, we got that. I got new wire from the disconnect to the unit, and we'll try to go directly into the contactors. All right, we got a new disconnect switch. We're gonna torque down everything. We pulled all new wire. It's ran up here in, runs up into there. We even ran a new ground because I didn't want to use wire nuts at all, because I happen to have the little connector for the big wire. So we're gonna screw the ground in. We tighten down these guys directly into the contactors, nice and good. Condenser fan motor's installed, new capacitor, that's good. And then we just need to torque these down. And every time I use this torque driver, this is the Weehaw torque driver. I got it from TrueTech Tools. You can check it out, use my offer code Big Picture, you get an 8% discount. I get a small commission when you do that. But I'm very surprised with how tight. This is calling for 50, what is it, inch pounds or whatever? pounds per inch, or, oh, good gosh. But the one tip I'll say is when you're using this torque driver, you got to make sure it's really pushed into there hard. Because if you look at this one right here, I don't know if you can see that, I didn't have it pushed in enough and it almost started to break the screw. Luckily I was still able to put it back on there and tighten it down, but yeah, you really got to get in there. And I always run them too, okay? So once you get it tight, back it off, run it in, back it off, run it in to smash the wire down. All right, we are running full blast, both stages. We're running about 32 amps. Nothing crazy going on here. Everything's running properly. Let's come over here. I know the maximum fuse size is 45 amps, minimum circuit size is 38 amps, so we're well under the 38 amps. Yeah, I'm not seeing any major issues on the unit. So at this point, we didn't find anything else wrong with it other than the disconnect wasn't making a good connection, and I didn't like how those condenser fan motor wires were getting brittle sticking out of here. So we put an OEM motor back on. We tested everything else as best as possible. And I forgot to mention, always leave extra fuses for the next guy. That way you have any more problems, there's new fuses sitting right in there. I always, when I change fuses, whenever I have the extras, always leave extras for the next guy. All right, it's been about a week and a half, 2 weeks, and the customer called and said their AC is not working again. So, let's jump into this and see what's up. Condenser's blowing cold air, so something's not right. What the heck? Let's open this up. Okay, so we come down here. This is interesting because condenser fan motors are running, but compressors are not. So let's go right here and I'm gonna check power. We wanna see if we have 208 3-phase, okay? A to B, B to C, and then the last one, B to A. So we have 208 3-phase going to this unit. All right, both condenser fan motors are running, but both compressors are not. The compressors are not hot to touch. So we go over here to the terminal board, X to C, and we have 25 volts. And what that indicates is that our unit is off on compressor lockout. Why though? Compressor lockout for both stages, because first and second stage is not running. So what the heck is going on here? The indoor blower motor is running, but oh, look at that. That's weird. Pulled in and held in. I wonder if that's just a lockout thing. Oh wow, what the heck? We're not off on lockout anymore. What the heck is that about? I don't know if that's how that works. I've never noticed that before, but now it's running. Huh. The indoor blower motor's running like it should be, so I don't see a problem there. Let's go have a look at the fuses, and then I guess we'll have to gauge up on this guy. I don't know if I said filters. I think I said fuses, but I meant filters. But the filters don't look too bad. I mean, they're dirty, but they're not plugged. So nothing to cause a low pressure issue. When we did our repair, we changed this condenser fan motor. We did not change this one. And this one is slightly overamping, which could cause a compressor lockout. So on here, it says the FLA is 1.37. And if we come over here, we're running at 1.46 right now. So that guy's overamping. This one right here is allowed to run This one's allowed to run 1.42. Let's have a look at what that one's running. That's this wire right here. 1.4. So this one's running fine. That one's overamping. So I'm gonna test the capacitors, make sure the capacitor's good. And if that's the case, then we're gonna change the condenser fan motor. Now, my logic here is something caused this unit to go off on either high head pressure or low suction pressure, right? Because it was off on compressor lockout. I'm assuming that when I pushed in the contactors, I reset the lockout or something, I don't know. But regardless, it was off on compressor lockout, or so we think, okay? The only thing that would cause it to go off on compressor lockout on both compressors is something common to both compressors. The odds of a low pressure situation on the first stage causing the second stage to shut off is not practical. So then you start thinking, okay, well, they have common condenser fan motors, and yesterday was probably one of the hottest days. It was like 108, 109. If they lost a single condenser fan motor, theoretically that would shut down both compressors because they would go off on high head pressure. Now the condenser's not too dirty. They are having some painting done at the moment to the building. I don't know if you guys can see the extension cord. It's run over to here. They've got painters painting the outside, so I was thinking maybe I'd come up and find a tarp on the AC or something, but no, that's not the case. So it seems like we've got good voltage. It seems like it's not the same issue as we had last time, because last time we were blowing fuses for some odd reason. And it, you know, ended up finding that the disconnect was not making good connections on line 1. So I'm thinking that we might have a bad condenser fan motor. So it's interesting, I've been gone. I got a new fan motor, fan blade, and capacitor. I've been gone for a little bit, but I would have thought it would have locked up by now, but it's not. It's still running over current though, 1.45 now, and it's allowed to run 1.37, so it's not huge, but I just don't trust it, you know? Like, and here's the thing with these ACs, they're getting so old, and this customer, you know, we can't get a new one right now. Like, you know, we've tried getting new ones, but this is an 04. The condenser's just beat down. Man, they put a lot of money into these units though, but you know, this is kind of how it's going right now, especially with the equipment shortages, you know. Previous to all this stuff, of course, we try to get them to change units when they have big repairs, but budgets just don't allow it. And then now we are up against a wall where you have these weird nuisance problems, you know. So anyways, we're gonna go ahead and replace that fan motor, all right? Visually, it doesn't even look very good. It's all rusted out on the side, but that doesn't necessarily mean it's bad, you know? We recently just changed this one about 2 weeks ago because the wires, remember, well, you guys see it in the video, the wires were all, you know, corroded and about to start cracking and stuff. So, all right, well, I'm gonna power it down, but yeah, it's been running for a good hour while I was gone. So I'm gonna power it down, change that condenser fan motor. We'll wire it back in. I also got a new switching relay, the condenser fan motor relay right there. Yeah, I got a new one of those too. We'll throw that in just as a preventative thing. And looks like we've got Japanese beetles plaguing me right now. I've got this Klein multi-bit driver. I love it because it has the 11/30 seconds on the end, and that's usually 11/30 seconds or 3/8 is what fan motor nuts usually take to tighten those. So I know some people have said, I mentioned it recently in a video too, that they've had problems with these, but I've had pretty good luck with it so far. I got it from TruTech Tools. If you guys go to TruTechTools.com, just look up Klein, you can find it on there. If you guys use my offer code, you can get a 8% discount on most all the items they have in stock, and I get a small commission when you use my discount code. My discount code is big picture, one word. So, all right, we got that guy in. I'm gonna put the blade on, drop it back down in, and get the wires all ran over. I always try to cut the wires short, so see how long they are, and we don't need that much. So I prefer to cut that instead of having bundles of wire up here. Same thing with capacitor wires. We cut those short too, and then try to route them in the best way possible. It's not always perfect. These things are kind of a dumpster fire, but we're doing our best. So I've got it all installed, got the new switching relay installed. Capacitors are in, motors are in, wires are safe and routed so they're not going to rub out. A lot of people ask why I run through these little knockouts right here. They're actually beveled knockouts, so they're not going to rub out the wires. You can see there's like a bevel to prevent them, so it's like an anti-chafe fitting or whatever. So they're actually meant to run wires through. So we're gonna go ahead and probe up on this. I know that I probed up in the beginning of the video, but like I had said, it's been a week or two, maybe 2 weeks, I don't know. But I want to be 100% sure there's nothing else going on this guy. So we're gonna go ahead and do a full measure quick setup on this guy and just make sure everything else is running as good as possible. I went ahead and rinsed off this AC, and their ice machine condensers. I don't know if it's what the painters are doing or what, but there was just a film on everything. So I rinsed all that stuff off. I'm waiting for the unit to stabilize out. The condenser's still a little wet. Again, investigating the kitchen heat, I come over here to their makeup air unit, which does have evaporative cooling on it. And I come over here, and the evaporative cooling pump is not circulating over the pads. We have cell deck media pads right here. And it's just like a paper material, and water evaporates when it runs across it with the air. So we're gonna pull out that pump. I went ahead and shut off the power switch for the pump right here. And we're gonna pull it out. I bet you it's just all dirty and gummed up. So I turned it back on. The temperature controller's calling, says 101 degrees. I felt the relay for the temp control kick on, but this pump is just locked up. It's not moving. So we're gonna go ahead and turn it off, and I'll go and get another pump while I'm waiting for that AC to kind of stabilize out. All right, pulled out the pump. It's just a 115 volt pump. Ran to the supply house, got a new one, slapped it in there. It's on and running. Now it's kind of hard for you guys to see, but it's moving water across the pads now, so that'll be a huge improvement for them. I'm gonna put this back together and then go follow up on the kitchen AC now. All right, let's go to circuit 1. This is 407C. The superheat's a hair on the high side, but with the subcooling as high as that, I'm not gonna add any more gas. This guy, and it may just be a simple fact of moving my air probe, because I have it kind of sensing the second stage more than the first stage, so it's getting a higher than normal return air temperature. So it is saying our target is about 8 degrees, so we are a little high, but again, we could have a fixed orifice metering device starting to plug up on this guy. But as far as suction pressure, well actually no, the suction pressure is not indicating that the air probe is sensing high air temperature. In fact, looking at the saturation temperature, looking at my targets, I'm actually pretty confident that we're starting to restrict the fixed orifice metering device. That would be a new evaporator. There's no cleaning those, and I've talked about that ad nauseum. So superheat is okay. It's not the greatest, but it's gonna be okay. Let's go to the second stage. Second stage is kind of doing the same thing. Superheat on that one's pretty darn good. That's a R22 system. I'm not too concerned about too much more on this. It's about 105 degrees outside air temp right now. See, my return air temp is 90 degrees at the moment. So yeah, you know, I mean, we might be messing the targets up a little bit, because it's 90 degree return temp. That is definitely getting outside air. But 55 degree, 59 degree supply air temp, that's decent. Temp split's huge, but again, it's mixing outside air. So not worried about that. Yeah, I mean, there's not much more I'm gonna do about this one. It really is polishing a turd, right? This thing is not gonna be perfect whatsoever. So I put a new water pump in their evaporative cooler. This guy's running. It was off on compressor lockout as best as I can tell when I got here. The only thing I could find was that condenser fan motor was slightly overamping. Put in a new one. It's running good now. Rinsed off the condenser just for the heck of it. And I'll show you guys the outside air probe. We can even try moving it and seeing if it fixes anything. But we're pulling outside air on this guy. You can see this is open to outside air. So if we move this down further, then that would be a little more accurate and be getting a little more return air temp versus outside air temp. You can see they pull outside air to make building balance work on this guy. So I went and fixed the air probe so that way we could get a better accurate reading, okay? So now that we look in here, let's go to circuit 1. Circuit 1's the 407C circuit. We're doing okay. Return air temp is 75 degrees. Subcooling's still a little high, about 107 outside. Superheat's about climbing a little bit, so 11 degrees. Subcooling's still 18, so let's go to circuit 2. Superheat's much better. Subcooling's about 22. We don't want it to go any higher than that. So, all right. What I did was, now that I think about it more and more, I actually closed up that economizer, because I think that has been left open for a while, because at one point the makeup air unit wasn't working and we had to make up the building air balance elsewhere, so we opened up outside air dampers. So I went ahead and closed that guy up because we've got the makeup air working and that thing's kicking butt. So we've only got a tiny bit of outside air coming in through this guy now, not as much. But this guy, I think, is doing everything it can. So we're gonna wrap this one up and just tell him to keep an eye on it. What a roller coaster, huh? So, you know, sometimes this stuff happens, and it just so happened that I hadn't edited this video yet. Usually I'm a little quicker on my videos, but
I hadn't edited it yet, and I was able to add that final footage to the video, but it it was kind of a headache. It was kind of frustrating. And as I was editing that too, you could see the first time that I was there, I tested that second condenser fan motor and it was running under current, right? Under the max current or the FLA. But the second time it was running over current, right? So you can never predict how this equipment's going to just dive bomb. Okay. Now, one thing I will say that as I'm editing it, I realized something. I never fixed that two compressors being jumped to Y1. I totally skimmed over that and forgot to address that issue. So I'm kind of wondering if we have a bad thermostat wire for the second stage. So both Y1 and Y2 are being turned on at the same time. I guess I was trying to think if, I don't know if that would cause the issue of going off on compressor lockout. No, it wouldn't, because they're both turning on at the same time if you get a call for, yeah. So I don't know. I definitely need to address that. So the next time we're there doing a PM or something like that, we'll bring it up to them, because that restaurant does do preventative maintenance. So we'll bring that up to them, and we'll possibly have to maybe change a thermostat. Those do have really old, what do you want to call them? Which kind of Venstar thermostats? So it's the old Carrier style, whatever. But anyways, it's got old Venstar stats, and they're junk, right? They've just been there forever, since '04, really, they're original. So we may need to look into that thermostat. We may need to see if we have a bad wire, but I still don't think that would have caused the lockout situation. I'm still thinking about it as we're going through this, but you know, the only thing I can do in this is, I'm not perfect, right? And I don't know the answers to everything, but I just take my troubleshooting one step at a time. I just start evaluating things. In the very beginning of the video, it was blowing fuses, right? And we didn't know why it was blowing fuses. I ran the insulation tester on all the motors that I could. Didn't see any issues. Okay, so that pretty much eliminates the motors, because if they had a failed insulation, you would see a low mega ohm rating, right? We weren't seeing that, so we eliminated that from the picture. So it's just a process of elimination, checking everything you can, watching the unit operate, making sure that it's operating properly. Okay, then at that point, start testing current. You know, seeing that the disconnect switch, thermal imaging cameras are great on disconnect switches. You can also use infrared lasers and different things to check the temperature. I would have been able to see that with a laser, just checking the top of the fuse to the bottom of the fuse. So more than likely, I think we had a loose fuse because the disconnect switch wasn't making good contact. And also, I didn't really get it on camera, but the disconnect knives, right? So you have a set of knives that pull into the disconnect like that, okay? They pull in and they make a connection right here. Sometimes those cannot make a full connection, and in this situation, they weren't fully engaging. They were just kind of like, you know, barely making contact. But then it seemed like the fuse wasn't, you know, getting grabbed tight enough, which could have caused a high current situation, which could have caused the fuse to blow. That was my best guess on that. So we changed the disconnect. We did a home run with the wiring, got rid of the big giant wire nuts on that number 8 wire, got rid of that, and ran directly into the contactors. And then we tested the unit out and everything was fine. I did change the condenser fan motor number 1 the first time. And the reason why I changed that, even though the motor was testing good, was those the rotation wires on the top, they were really brittle. And if I would have taken my fingers, I could have snapped them. Like, that's how hard the jacket was on those. So I knew that was going to be a problem eventually. Okay, so eliminated that. Plus that motor just looked like junk, but we don't change a motor just because it looks rusty. You know, we have to find a valid reason. One of the reasons why I don't like the aftermarket motors is because of those wires. They tend to just be sitting in the heat, and over time they get brittle and can break and cause shorts, just becoming a problem, right? So eliminated that. Then a couple weeks later, they called me back, and it was a different issue though, because we weren't blowing fuses now. Now we were off on compressor lockout. And so that's when I went through, tested the second condenser fan motor, went through everything else. I did change the condenser fan motor relay because the compressor contactors and the blower motor contactor had previously been replaced and they were still in good shape. But that condenser fan motor relay, I have no idea. It's a totally enclosed relay. I don't know what the inside looks like. It was just, I just eliminated that from the picture. Okay, so put a new relay in there and just went through everything else. I can't find anything else. Unfortunately, this is happening more and more, okay? This equipment is getting older and older and older, and we're starting to see a lot of problems. This particular customer stopped preventative maintenances during COVID, right, for a good year and a half or so, and then started them back up to normal routine stuff. So we're doing it regular, but a lot of the damage was already done. Plus, that equipment was already really old. You figure 2004, I mean, you know, it's just beat down. Now, granted, I know we all have equipment that's older than 2004, but you have to think in the 2000 timeframe, that's when the quality of equipment started going downhill. It wasn't at its worst, but it started going downhill. So anything, for the most part, you know, general grade equipment like this Carrier, this is like an economy model, anything like this, if it was installed in the 2000s, it's basically on borrowed time. Okay. Now you can get some higher end equipment that might be lasting a little bit longer. It's unfortunate because, you know, I've replaced stuff that was from the 60s and it was still working. It just wasn't efficient anymore. Right. But you don't have equipment from the late 90s, early 2000s lasting as long these days. Okay. Especially on these Carrier units because they have the fixed orifice metering devices. And those things are just horrible. When the condensers get dirty, it starts fouling up the oil. The oil just gets thick and starts restricting the fixed orifice metering devices. Like this one kind of seems like we might have a slight restriction. They're just beat down. So I can only do what I can do. I kind of felt bad, but then at the same time, when I went there, it's not the same issue. I charged for all my time, you know, and the customer understands it. They trust me, but still it kind of sucks having to go back a couple weeks later. You know, I was thinking that it was going to be my fault, but no, it's not. So I just do my best. I can only do my best, right? That's all that, you know, we can give them. So I really appreciate you making it to the end. Thank you so very much. Check out my website, hvacrvideos.com. Got some merchandise available there, hats, shirts, beanies, sweaters, all that good stuff. Mention it several times in the video. If you're interested in tools, truetech.tools.com, use my offer code. You can also support the channel via PayPal, Patreon, YouTube channel memberships. There's links in the show notes of this video. Leave me a comment. Give me some feedback. What do you think? Do you guys have a solution for that chase nipple being longer? I need a better solution there with that. I don't want to use pipe or anything, but I want a better solution for the chase nipple. So let me know on that. Other than that, be kind to one another. Be good humans. I really, really appreciate you. And we will catch you on the next one, okay?